A lot of businesses make the jump to the cloud expecting instant modernization, but without realizing it, they bring an outdated mindset with them, treating dynamic cloud environments exactly like the old physical servers sitting in a basement. That approach leaves you with static infrastructure. Just like a block of ice, when hit with sudden pressure, it doesn't bend, it fractures. This is what we call fixed capacity hosting. You're pre-purchasing a set amount of computing power based on a guess, and you pay that flat rate whether you use those servers or not. This leaves you with a difficult choice. Do you stick with the predictable safety of provisioning your own static servers, or do you take on the complex engineering work required to transition to automated scaling? Holding on to fixed capacity is a silent, continuous drain on your capital. It actively eats into your profit margins every single hour your servers sit idle. To understand how that capital drains away, look at how we provision. The standard practice is to buy enough capacity to handle the highest expected traffic events, just to guarantee the site survives a big event. This diagram illustrates the problem. A flat, horizontal line represents static server capacity, alongside a highly volatile line for user traffic. During quiet hours, the capacity you paid for sits way above actual traffic. That gap is wasted capital on idle servers. Then come the danger zones. When a sudden rush hits, traffic bursts through your capacity threshold, causing complete downtime. If you rely on a human operator to spin up new servers in that moment, it's already too late. A manual response is simply too slow to stop the crash. Over-provisioning gives you a false sense of security. You are trading away massive amounts of operating capital for a rigid system that still fails exactly when your business needs it most. This matrix compares static provisioning against automated scaling. With cost efficiency, the static model gives a predictable flat bill, but guarantees high capital waste. For spike resilience, static is highly vulnerable. Overwhelmed servers destroy sales long before your team can react. There is one clear advantage here. Setting up static servers requires low architectural effort, and your accounting department will appreciate the perfectly predictable monthly invoices. But that predictability comes at a steep price. Because of their rigid design, static environments actively penalize your business for experiencing sudden growth. The alternative is automated elasticity. This is a dynamic system designed to seamlessly expand and contract your compute power based strictly on real-time performance metrics. Moving to the automated column, outcomes are clear. You maximize cost efficiency by eliminating waste and ensure high uptime by absorbing spikes. But there is a cost. You lose that predictable monthly invoice and must drastically change how applications are built. To make automated scaling function safely, your engineering team must adopt a stateless application design. Stateless design means decoupling your application's components. You can no longer rely on individual local servers to hold crucial user data or save the state of a transaction. Instead, all of your user session states need to be externalized to databases or distributed caches like Redis. The data cannot be trapped on a single machine. When you externalize that information, your automated systems can instantly destroy unneeded server instances or duplicate new ones without ever losing a customer's progress or dropping their shopping cart. The financial savings of autoscaling are tied directly to technical debt. You realize these rewards only after you invest the engineering hours needed to decouple your architecture. Looking at the management style row, automated scaling requires moving away from passive end-of-month bill reviews. Instead, you need a proactive FinOps governance framework. This aligns engineering decisions with real-time financial accountability through clear cloud policies, automated alerts, and budget tracking. Those strict cloud policies and automated alerts are your safety net. Without them, a single glitch or a runaway script could command your system to infinitely scale servers, effectively bankrupting the company. Furthermore, real-time budget tracking ensures that your automated decommissioning processes are actually doing their job, removing unused assets to immediately halt unnecessary billing when traffic drops. Achieving true elasticity is an operational evolution. It requires accounting and engineering teams to synchronize their goals and manage cloud costs as they occur. Is the upfront modernization effort worth the investment? Let's look at this scorecard to see where you fit. On the left, the high variance operator. These are e-commerce or SaaS companies with volatile traffic, crash risks, and rapid growth. For these businesses, taking the hit on the immediate upfront cost to re-architect into a stateless design makes sense. That investment will pay massive, compounding dividends in saved capital and protected revenue. Now, let's shift to the right side of our scorecard, the legacy monolith. These are organizations running deeply stateful, highly coupled applications with significant technical debt. These legacy systems tend to experience highly predictable, flat baseline traffic day in and day out. If you fall into this category, the immediate engineering cost and the risk of decoupling your systems may temporarily outweigh the marginal savings you'd get from dynamic scaling. For legacy operators, attempting a fully automated elasticity migration right away is a mistake. Incremental code modernization has to take priority first. The reality is that there is no single correct cloud strategy for everyone. Your financial path depends entirely on whether your specific audience traffic is volatile enough to justify the architectural overhaul. Successfully deploying automated scaling turns your infrastructure into a responsive asset. It stops being a fixed liability on your balance sheet and starts adjusting in real time to your actual traffic. Adopting this model requires modernization across two fronts: your application's code and your team's financial governance. Moving away from fixed hosting is becoming a financial necessity. As margins tighten, companies that continue paying for idle power face a direct competitive disadvantage. Remaining stagnant with a static cloud model guarantees two things: long-term financial bloat and critical vulnerability exactly when the market tests your capacity. It is time to stop paying for idle air. Adopt dynamic infrastructure that scales your resources, protects your uptime, and grows exactly when and only when your business does.